Hello everyone, we are coming to new lecture, unit number 5. We are going to talk about the product moment of inertia for rectangular section. We want to prove that the product moment of inertia for rectangular section equal to 0. We drew first rectangle, the base is B and the height is equal to h, and we introduced the external two axes x and y. Then we come at the CG, we draw another two axes, which are x dash and y dash. We divide this rectangle into 4 areas, namely A1, A2, A3, A4. And for each area, we are going to locate the CG of every area. For example, A1, this is the area, the width is equal to B over 2, the height is equal to h over 2. And for area number 2, the CG lies to the right of the y dash axis by distance equal to b over 4 and above the x dash axis by h over 4. And similarly, we can draw A3 in the third quarter and A4 in the fourth quarter. For every area, we are going to estimate the product moment of inertia about x dash and y dash. We are going to proceed as follows: ixy at g, where g is passing by the center of the area, for the first area will be equal to the A1 multiplied by horizontal distance multiplied by the y distance. The horizontal distance for CG of the A1 equal to minus b over 4. This is the horizontal distance, we call it x, x1, y, and y1 will be h over 4, but it will be plus sign. So A1 multiplied by minus b over 4 multiplied by h over 4 will give us A1 multiplied by minus b h over 16. While for the ixy ge for the area number 2, it will be equal to A2, the x value, which is x2, equal to b over 4 plus sign, while the y2 equal to h over 4 plus sign. Our ixy at g for A2 will be equal to A2 bh over 16. For the area number 3, we have horizontal x distance equal to minus b over 4, and we have y distance to the CG equal to minus h over 4. That's why the product moment of inertia at the CG for the area A3 will be A3 multiplied by minus, and minus will become plus of the same value bh over 16. Finally, for the last area A4, the product moment of inertia for A4 will be equal to A4 multiplied by plus b over 4 multiplied by minus h over 4 plus multiplied by minus will give us minus sign bh over 16. Knowing that all these areas are equal, so A1 equal to A2 equal to A3 equal to A4, and each area of these areas equal to b over 2 multiplied by h over 2. That's why this every area is bh over 4. So instead of A1 and A2, A3, A4, we are going to write only one area, which is A1. If you add minus and plus, they are the same value with terms to 0. And again, we have plus and minus of the same value with terms to 0. That's why A1, which is a big area, will be multiplied by 0. At the end, the summation of ixy about g, the center of gravity of the rectangle, we are going to use this summation from a equal to 1 to a equal to 4 will be turns to be 0. That's why for symmetrical section, we'll find that ixy value will become 0. That's why we will call this x dash and y dash principal axes. The principal axes, they are the axes for which the product moment of inertia will be equal to 0. But some sections, they don't exhibit such property. That's why we are going to readjust these axes, but this will be discussed later on. The same result can be obtained for the product of inertia by introducing this rectangle for the bottom left corner with x and y. And here we are going to draw this our strip dA with breadth equal to b and with width equal to dy. But in that regard, our product moment of inertia will be equal to the area of the strip multiplied by the x value from the CG to the y-axis, multiplied again by the y distance from the CG to the x-axis. Since this is a rectangular strip, its horizontal distance will be x over 2, which is equal to b over 2. So our ixy equal to the integration, our starting from y equal to 0, and our end is y equal to h. And inside the integration will contain b dy, which is the area, b dy, multiplied by x over 2, multiplied by y, while our x over 2 equal to b over 2. So we have b over 2 multiplied by b, which is will give us b squared over 2, multiplied by y dy. We get b squared over 2 outside, and after making integration for y dy, it will become y squared over 2. We substitute starting from h minus the value when y equal to 0. So we have b squared over 2. Again, we divide by 2 would become 4. And we open one bracket, h squared minus 0. At the end, we have ixy b squared h squared over 4. Since the area, the big A, equal to bh, so we can write that this expression ixy equal to the capital A multiplied by bh over 4. This is the product moment of inertia about the external two axes at the corner, x and y. If we want to estimate the product moment of inertia at the CG, we have to deduct the area multiplied by the xy, x bar by y bar. Our x bar is b over 2 and our y bar is h over 2, all multiplied by area. So again, our ixy, this is ixy at G, and this is our ixy. So our equal to capital A B h over 4 minus the area multiplied by b over 2 by h over 2 would give us same result, bh over 4 multiplied by capital A, which is the same result. At the end, it will give us 0 value. Thanks a lot and see you next lecture. Goodbye and take care.